everyone. I'm Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. Today, our students of second year BME are going to give a demo for Programmable Function Generator using LabVIEW and time and frequency representation of physiological signals. Here we include some physiological signals like EEG, ECG and EMG. And we know that with the help of LabVIEW, we can easily interpret the results of our instruments. Let's see how it will be.
Good morning everyone, myself Siva Harunya, and in biomedical engineering, signal analysis and signal generating are main tools for this, and this case study focus on tools and LabVIEW helps to use this, and we focus on two programs, that is programmable devices and time frequency domains, and the waveform to generate sine waves and square waves and triangle waves, and this waves to generate the forms like ECG, EEG and EMGs, and these are in biomedical engineering domains.
Hello everyone, I am here to explain the programmable function generator. Now we see that in the block diagram we know that different functions, that is x star y into 5 and x star y into 2 and x star y and y star x star y into 3 and x into 2. Some different function we get the functional these functions to into a graph that can be produced in the output. So now we see we mainly use three components: harmonic analysis and multi-generative AI and this sample informing, and we can use some mathematical instructions, that is arrays and this is arithmetic devices. So now how can we set this? So first right click in the mouse and take numeric and go the array. So in that array we find one bundle, array bundle. So you can set this and we can use this like, then we can come the graph sheet and get numeric controller to question it and use this to connect this. So in that, like that, we can connect all into this. So next we can go the search bundle and go just. So we search a multi-generative and to take it and place this and connect it. So in that you place your mouse and to right click you can create an indicator. So we can found that and we can get the output in the graph sheet. So that like we can place all elements in this like. So in this function we can use different types of functions to multi-generative by a bullet array, and that will go a harmonic analysis. In the harmonic analysis, three different ways we will get the output. In the harmonic analysis, it analyzes these five functions and that goes to unbundle, and once this is simple error detection handling. When the error come to that harmonic analysis, the error handling will handle that error. So you use that error handling and commons level. When the functions commons level is detected by the commons level, and the waveform graph, we can give different inputs to these functions. So that waveform will come from the waveform graph. So that waveform and the exported spectrum, we can find the spectrum level of this waveform. So we can use that exported spectrum and we can that will be generated by the unbulled block. So in the unbulled block we can find the exported spectrum for the different types of functions. So that we can use the exported mode. We can use this fundamental signals. So we can use this exported mode is fundamental signals. So that will connected to the harmonic analysis, because the harmonic analysis handle all functions and unblocks to in so that can work and give the waveforms and the outputs like exported system, detected fundamental frequency and the commons level. These are shows in this side. That's all.
Now we are going to see the simulation of ECG, EEG and EMG through the NA LabVIEW monitors. First we have to place a while loop by clicking right clicking the functions button and add the structures to the front panel, which has a while loop, and the while loop can be drawn here itself. After the drawing the while loop, you should take the simulate signal generator, which is from the express panel, and you should select the input. Here you can see the simulate signal options. Once the simulate signal is seen, you can place it inside the while loop. Once the simulate signal is given, for ECG we have to keep the sine wave signal as signal type and frequency as 1 and amplitude as 1 itself. After it, you can give OK to simulate a ECG wave signal. And here is the ECG. And then on the block diagram chart, we should keep a waveform chart graph which should display the output and connect the simulate signal block with the waveform chart block. Then, as the same process repeat, click express and goes on to the input. There you should have to select the simulate signal option. As the same option repeats, we should keep different parameters for EEG. As like that of same sine type, but frequency should be changed to 10 frequency and amplitude as 0.1. The time delay sample per second remains as 1000 only. Once it is given, ECG generator is generated, and the waveform chart is created as in the ECG. Both EEG generator and waveform chart are connected to get the output. As the process repeat, same process is repeated to the EMG generator. The properties for this, the sine wave, and we have to the frequency is 100 Hz and the amplitude is 0.5. In addition, we have to add noise to this wave. The main noise is used for this. We can use various type of noise, but for generating a clear EMG wave, we should add a Gaussian white noise. Once it is added, the standard deviation swing hour will be displayed. Samples per second remain as 1000 only. So click OK to generate it. After confirming it, we should add a waveform chart as we done in ECG and EEG and connected the generator with the waveform charts. After this, we should add a timing block to set a delay time. Once it is set on right clicking this, we could create a constant to place it as 100, and the time delay is set as 100, and we should add a stop button by clicking the block diagram as a boolean. We could see a stop button. Once the stop button is placed in the front panel, here on the block diagram panel we can see the block stop button. The stop button should be connected to the while loop end. Once all is done, we should run the program. The waves will be generated like this, and we can stop the simulation by clicking the stop button. Thank you.
Conclusion: the developed VIE provides a flexible and efficient way to form the waveform generation and in biomedical signal analysis. It helps us to, the use of LabVIEW helps us to in a user-friendly manner and cost-effective. Overall, this approach improves understanding of biomedical engineering in research applications. Thank you.